Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we continue talking about multi-threading and how we can put parallelism into our programs. Now, in the previous videos on parallelism, when we were talking about multi-threading, we were using the most basic features that came basically with the first version of Java. The ability to use things like synchronized and to create threads directly from the thread class and to use wait and notify. Now, at a fundamental level, these constructs are sufficient for you to do whatever you want. But hopefully you've seen there are some pitfalls in them. And indeed, the creators of Java noticed this. And for that reason, with Java 5, they added a new package called the Java util concurrent package. And so this package, if we come into the Java API, Java util concurrent, in this package, there are a number of different classes that can help you with doing things that are commonly done in parallel programs. And so we're going to go through and look at a number of these in this video and then the ones after it. So to start off with, instead of using threads directly in Java util concurrent, they wanted to abstract the idea of processes being done, and they create an interface, which in Scala we think of as a completely abstract trait, called an executor. And the executor is fairly simple. If we come down here, it has one method called execute, and it executes a runnable. And so we've seen runnables before. We saw them with threads. That's what we passed into a thread to get it to do stuff. All this says is that objects of the type executor will have the ability to execute a runnable. So they will be able to go off and run it. The thing is that whereas a thread, when you did this, said in all cases it was going to create a new thread and run it as a new thread, the executor abstracts this, and it doesn't actually necessarily tell you how it's going to execute that runnable. Fundamentally, it could do it in the current thread. It could do it in some other thread. It might not start in another thread immediately, whereas the other threads, when you do that with a thread, it does say immediately go off, make this thread, and then as soon as it gets scheduled to start working on it, maybe it does something more elaborate in there. And so this helps you because then you can choose exactly how it's going to be run. You make a different executor, and different executors run things in different ways. Now, just having an execute method is a little bit too simple, and so most of the time when you're actually using these, you'll actually use an executor service. Now, the executor service is a subtype of executor, so it inherits from executor. So super interface is executor, it inherits from it, but it adds a whole bunch of methods into here. You can still do the execute on it because it is an executor, but most of the time instead of calling execute, you're going to call submit. Now, this submit method basically does the same thing as the execute, but there are a few minor differences. And so if you do this submit here and you pass it a runnable, that gives you a very similar type of behavior, except for this actually returns a value to you. If we go back and we look here, notice the execute returned void in Java, which in Scala would be the same as returning unit. It doesn't give you back any information. There are three versions of submit here, and they all give you back a future object. And so we have to talk a little bit about what exactly that means. Notice that these second two submits take runnables. This first one, in some ways the ones that we're most interested in, takes an object of type callable. And this callable has a type parameter, what in Java is called a generic, of t. And it returns to you a future of t. One of the problems that you might have run into with threads, and the things that we've discussed previously, is you could start something happening in another thread, but that calculation could never return a value to you. Okay, that was a significant limitation. Now, you could make it return a value kind of by explicitly writing code so that you create a variable and you store that value in that variable, when the calculation is done, and then somehow orchestrate things so that you don't have race conditions on storing things in that variable. You can write that code using what we've talked about already, but it's a pain. And it's something that you want to do a lot. And for that reason, they created the Executor Service and they put in a submit method. And when you submit to it, you can give it a callable. And if we look at callable is actually very much like runnable, except instead of having a run method, it has a call method, and the call method returns something to you. Whereas run didn't give us back anything, call does give us back a value, so that we can write callables and have it so that they return some value to us. Now, the last question, so there's a lot of other methods. You can go and read the API for this, for how you would go about dealing with these executor services. But the last thing I want to talk about in this video is the question of how do we actually get hold of an executor service? How do we create one of these? Remember that being an interface means that this is like a completely abstract trait, and you cannot instantiate traits. So how do we get hold of these things? And how do we get hold of ones that use submit in different ways? Because I mentioned the advantage of the executor and also of the executor service is that this interface doesn't tell you how it's going to run things. Different subtypes of it can choose to run things differently. And the way that you create these normally is to use the Executors class, and it has a number of different methods which give you back executor services. Okay. So you can make a new cache thread pool, a new fixed thread pool, a new single thread executor, and there are some others in here as well. Those are the three main ones. Obviously, the single thread executor has a single thread, and when you submit a task to it, if that thread is already busy, it just waits until the thread is not busy. As soon as the thread is not busy, your task will get put on it. But it basically gives you one additional thread in addition to the main thread. A fixed thread pool, you can say, I only want to have, say, 10 threads. And then if you submit 10 or fewer jobs to it, they will all run on separate threads. But if you start submitting more, what will happen is that the additional ones will wait until one of the other jobs, one of the other callables, the jobs that you submit, finishes, and then they will get started. The advantage of doing this is, actually there are several advantages to it. One is if you know that the machine you're on only has, for example, 8 cores, well, there's really not much point in starting up 500 threads. In fact, if anything, starting up 500 threads is going to slow you down in that case, and can slow you down quite significantly. And that leads to the other benefit of this. It turns out that creating threads has a significant cost to it. Every time that you create a thread, it sets aside a fair bit of memory, and there's quite a bit of overhead to it. So you really don't want to create lots of additional threads. By using a fixed thread pool, you can say, hey, I want to have exactly so many threads, and it will create those to start with, and then it will keep using them over and over instead of making new ones. The other option here, the new cache thread pool, doesn't have a maximum number, but it does reduce the overhead of creating new threads. So if you create a new cache thread pool and you immediately submit 10 jobs to it, it will make 10 new threads, one for each of those jobs. But when those jobs are done, it won't just throw away the threads and forget about them. It'll keep them around. It will cache them. And then when you submit another job later and it needs to have a thread, it will look to see if it has any threads that aren't currently active. If it has a thread that's not currently active, it will give the job to that thread. If all the threads are currently active, it will go ahead and create another thread. But by using these, you can reduce the number of total threads that are created. So this runs you through kind of the basics in the API for the executors, executor services, and how we can use the executors class to make new executor services. In the next video, we'll come back and we'll write some code that actually utilizes this to solve a little problem and to do it in parallel. And it will also demonstrate exactly how futures come into play when we do this.